Well, in the previous video, we did solve this question 2, that says determine the arithmetic sequence of the first three terms of an arithmetic sequence is given by 4, 13, 20, and 22. We did work out question 2.1 and question 2.2. Now we're going to do question 2.3. Okay, let's see question 2.3. Well, that says consider the term of this sequence which are even. Okay, calculate the terms of the sum of the first 25 terms which are even. All right. Here they say calculate the sum of the first 25 terms. So this is Sn, the sum of the first 25 terms. So right here, this is like, it means we're talking about the Sn. Okay, so now let's just move this a little bit here and then draw a line to separate the new work with the previous one. All right. I'm going to paste the new work here so we can also have it over here. The question says consider the first. This is question 2.3. Consider the first term, consider the terms of this sequence which are even. So we're talking about the even terms that are even. Okay, even are those numbers that we can divide by 2. Calculate the sum of the first 25 terms which are even. All right. So in this question we're looking for S25. What do we know about Sn? We do know two formulas. Okay, let me move this. I'll move this one a little bit over here. So this will be there. You see, S25 is what we're looking for. And then Sn is given by n over 2, open square bracket 2a, plus n minus 1 times d. Or Sn is also equal to n over 2, a plus l. Okay, these two are the formula for n. So now, the terms in the sequence were like 4, 13, 22, 31 is what we found, and because we discovered that the constants difference is 9, we can just plus 9 over and over, and then see how the sequence will changing. Okay, will be changing. So okay, if we extend the sequence, it's gonna be like that. Now the question says consider the terms in the sequence that are even. So we can see, again, I will highlight here the terms that are even. 4 is even, but 13 is not. 22 is even, 31 is not. 40 is even, 49 is not. 58, 76. Those are the even terms, okay? So now, these even terms can form another term, another sequence of like 4, 22, 40, 58, 76, etc. Okay, so now here we can discover that we have a new constant difference, which is of 18. Okay, if you can notice that the constant difference is just 18. Now we can then we can say, okay, even the even, excuse my English, even the even part of this sequence is also an arithmetic sequence because it has a constant difference. Then we can apply the formula here. So we can say Sn will be equal to, okay, we can apply this formula. We say then Sn will be equal to n over 2. N, how many terms? Let's say 25 terms, because here, so n is 25, so it's going to be 25 over 2 open square brackets, 2a, which is 4, close, plus n minus 1, n is 25. Makes 25 minus 1 times 18. And then Sn will be, if we type this in the calculator, we're going to get 5,500. Sn is 5,500. All right. This is one way of solving this problem, but we can also solve the same problem by using this other formula. Okay. Okay, but this formula is used only when the first and the last terms are given. Like in this question, this formula will be used in any cases. Okay. This used in case, but this one only when the first and the last term are given. But sometimes if the last term is not given, we can find it and then we substitute it in here. So like the last term is not given. The last term we know is Tn, right? Tn is given by a plus n minus 1 times e. So the last term Tn will be T25, which is a. The first term is 4 plus n minus 1. N is 25 minus 1 times d, the constant difference, which is 18. Okay, and then we can use a calculator here, and then we solve this. So this will be equal to 436. Then that's the last term. Then we can then use this formula Sn will be the first term, which is 4, or the first n over 2, so 25 over 2, open bracket, the first term, which is 4, plus the last term, which is 436, and then this equal to 5,500, that's Sn. Thank you.